Hello students, in our first chapter, Geometry. Today we are going to learn conditional statements and converse. In geometry we learn many properties and sometimes we have to prove these properties. The properties proved logically are called theorems. The statements of these theorems are given. These theorems are in conditional form. First, we will see how to write the statement in conditional form and its converse. Okay. Now, what is conditional statement? Conditional statement means the statements which can be written in the if-then form are called conditional statements. The statements which can be written in the if-then form are called conditional statements. Now here in conditional statement, two parts are there. The part of the statement following if is called antecedent. The part of the statement following if is called antecedent, and the part following then is called consequent. Now here, one statement is given here. Statement: the diagonals of a rhombus are perpendicular bisectors of each other. Now this is given statement. Now, if you write this statement in if-then form, then this statement is called conditional statement. Now this same statement we can write in conditional statement like this. If the given quadrilateral is a rhombus, then its diagonals are perpendicular bisectors of each other. Now, this statement is written in conditional statement. And this type of statement is called conditional statement. So, in this conditional statement, two parts are there. The part following if, that means one part is the given quadrilateral is a rhombus. This is one part. And the part following then, its diagonals are perpendicular bisectors of each other. This is second part. Now, the part of the statement following if is called antecedent. Is called antecedent. The first part, that means the part following if the given quadrilateral is a rhombus. This part is antecedent part. And the part of the statement following then is called, that part is called consequent. Consequent. So in this statement, the part of the statement following then, this part, this part is consequent. In this way, for conditional statement, two parts are there. The first part is antecedent and second is consequent part. Now, the conditional statement, we can write the converse of this conditional statement. That means the parts antecedent and consequent, if this part are interchanged in the statement, then the statement is converse. That statement is called converse. That means if the antecedent and consequent in a given conditional statement are interchanged, the resulting statement is called the converse of the given statement. Now we will write the converse of this statement. The converse of this conditional statement. Now here these parts antecedent and consequent, these parts are interchanged. Here, if the diagonals of a quadrilateral are perpendicular bisectors of each other, diagonals are perpendicular bisectors of each other, then it is a rhombus. Is a rhombus. This is called converse of this theorem. So now we will see how the statements are used to write the proofs of theorems. So before that, remember one thing, that if the conditional statement is true, its converse is not necessarily true. That means every time the converse may not be true. If the conditional statement is true, but every time converse may not be true. Sometimes the converse is true, but in some examples it is false. Remember these things. Now in our next topic, we will learn how to write proofs of theorems. But before that, we will study what are postulates, what is meant by theorem. First we will study postulates. So postulate means self-evident geometrical statements. Self-evident geometrical statements are called postulates. You know that a Greek mathematician Euclid, who lived in the 3rd century before Christian era, he gathered the knowledge of geometry prevailing at his time and streamlined it. He took for granted some self-evident geometrical statements which were accepted by all and called them postulates. So there are many postulates. We will study one by one. Postulates means self-evident geometrical statements which were accepted by all. Now we will see some postulate here. Postulate 1. There are infinite lines passing through a point. There are infinite points passing through a point. In your textbook, page number 9, some postulates are here. Among those, first is, there are infinite lines passing through a point. Suppose this is a point, any point, and we can draw many lines passing through this point. See here. For example, this is point, suppose point P is here. So we can draw many lines. See here. In this way, we can draw infinite lines passing through a point. This is the first postulate. The second postulate is there is one and only one line passing through 2 points. Suppose here 2 points are there. And there is one and only one line passing through 2 distinct points here. We can draw only one line. We cannot draw another line passing through these 2 points. So this is the second postulate. And the third postulate, a circle of a given radius can be drawn taking any point as its center. If you want to draw a circle of a given radius, suppose you want to draw a circle of this radius, so you can take any point as a radius, you can take any point as a center of that circle. If you take any point anywhere as a center, you can draw a circle of the given radius. Or you may take point here also, you can draw a circle. That means any point you can take as a center of that circle. Now the fourth postulate is all right angles are congruent with each other. All right angles are congruent because you know that the measurement of right angle is 90 degrees. This is 90 degrees. This is 90 degrees. This is 90 degrees. So 90 degree, 90 degree, 90 degree. Therefore, all right angles are congruent angles. This is also one postulate. Now the next postulate is if two interior angles formed on one side of a transversal of two lines add up to less than two right angles, then the lines produced in that direction intersect each other. Suppose these are two lines. Lineal, yeah. And suppose this is a transversal line here. Now see here, these are the interior angles. On one side of the transversal. If two interior angles form on one side of a transversal, suppose these are two interior angles of two lines add up to less than two right angles. And if we add these two angles and this sum is less than 180 degrees, sum is less than, suppose this angle A, this angle B, that means angle A plus angle B is less than 180 degrees. Then if this sum is less than 180 degree, then if we increase or if we draw this line forward, these lines will intersect each other. This is the postulate. If two interior angles formed on one side of a transversal of two lines add up to less than two right angles. Two right angles means 180 degree. 90 plus 90. Then the lines produced in that direction intersect each other. That means if we produce this line in this direction, then these lines will intersect. See here, these lines are intersecting. Suppose here point P. If this sum is less than 180. These are some postulates. Now next time we are going to study the proof of the theorem.